Hello guys, you are welcome to our new program where we will be solving fast question papers, both Waec, NECO and also JAM, bit by bit, that is topic by topic. So today we are going to look at chemistry where we will start solving fast question paper from 2017. So the question says, what phenomena is exhibited by an element X which exists as, that is element Z, atomic number 17 and 17 again, with the mass number of 35 and 37. This is question 1, Roman figure 1, that is Roman figure 2. What account for the difference in the mass numbers of the elements? Roman figure 3 says, calculate the relative atomic mass of Z if the percentage abundance of. So this is what we mean by isotopy simply. But when we say isotopes, is atom of an element that have different mass number. But when we say isotopy, is a phenomena or ability. So the isotopy is the process, phenomena, ability, while isotopes are the atom of the elements that are capable of existing with different mass. So this is our answer for the Roman figure 1 of the question. So Roman figure 2 is number of neutron. Number of neutron is what differs the two atoms. Why? Because they are having the same atomic number but different mass number, and mass number is affected by number of neutron. So Roman figure 3, said to calculate the relative atomic mass, that is relative atomic mass of 17 with the mass number 35, Z 17 with the mass number 35, yes, Z 17 with the mass number 35 with an abundance of 75%. So to calculate the relative atomic mass of an element by percentage, so the percentage abundance will be multiplied by the atomic mass number of the element. Since we are having two atoms of elements given, that is isotopy, they exist with different masses, so definitely our Z, that is our Z17 with atomic number 37 will also be equals to 25% in the combination. Why? Because we are calculating it with the percentage, and this one is given as the as 75%, so definitely the remaining one is 25%. So to calculate the relative atomic mass, you have to say the relative abundance of the element multiplied by its mass number, that is for the A, plus the relative abundance of element B multiplied by its mass number. So let's 75 multiplied by 35. Yeah, the percentage abundance by the mass number. This is of A, plus percentage abundance of the second one, 25 multiplied by 37. So if you multiply 75 by 35 and add it to 25 by 37, you definitely have something of this nature. 35.5. So your relative atomic mass is 35.5. Question 2 said, what are nucleons? So nucleons consist of protons and neutrons found in the nucleus of an atom. For instance, this is an atom. This is the core center of the atom, and electrons are revolving around here. So there is proton, and also neutron here in the nucleus, where this is called nucleus, and this side is called orbital or shell. This is orbital or shell. So the nucleons is here, where it contains proton and neutrons. So question 3 says, the electronic configuration of an element X is 1s2, 2s2, 2p6, 3s2, and 3p5. Then the question says, Roman figure 1 says, deduce the atomic number of the element. That is Roman figure 1. To what group does X belong? Roman figure 2. Then give two properties of the group to which the element X belong. That is Roman figure 3. Then Roman figure 4 says, identify element X by name. To deduce the atomic number of the element, simply you have to add the powers. What are there at the superscript of the configuration. So when you add these two with this 6, you are having 10, together with this 5, 15, and 17. So the atomic number is 17. This is the Roman figure 1 answer, while Roman figure 2 says, to what group does X belong to? So to find the group of an element, simply, if its electronic configuration is given like this, so you are to add the last electronic configurations with the second, that is the powers. You have to add the power of the last and the second. But mind you, if it ends with S, that is S block, you cannot add anything. But apart from S, you must add the two of them. But for instance, if it ends here, that is 3s2, so definitely it will be in group 2. But here it is 3p5, so we must add the powers. So if you add the powers, definitely it will going to give you group 7. So this is a simple and easiest way if you are given electronic configuration of element and you are asked to find the group of the element. From figure 3, there are non-metals, there are properties. They form the atomic molecules, and also they are oxidizing agents. So these are some of the properties. Write the subatomic particles with their corresponding relative masses. Bring them together with their charges so that they can have because you may be asked somewhere. Proton, neutron, and electron are the subparticles. Wherever you heard of subparticles, so proton, neutron, and electrons are the subparticles. So they are also having charges. So proton is having +1, that is positive always, while electron is having -1, negative always. And also neutron with no charge, it has no charge, that's why I put nil. It has no charge. So the mass is, for the proton, the mass of proton is 1, while that of electron is 1/1840, and also that of neutron is also 1. So we are only asked in this question to bring the subparticles together with their masses, but I decided to bring this so that they too they can have. Question 8E from 2008 says an industrial raw material has the following composition by mass. Iron, is equals to 28.1, chlorine 35.7%, water of crystallization 36.2%. Then calculate the formula for the material. As we have extracted our data from the question, so iron, so I have to say 28.1, then chlorine is 35.7, and also water of crystallization is 36.2%. Mind you, you have to write them serially according to how they are given in the question for better understanding. So first step, you are to divide the percentage composition of the elements given in the question by their mass number. The first step. So let's divide it by their mass number. So here is iron. So iron is having 56. Then this is chlorine. So chlorine is having 35.5. Then water of crystallization, since hydrogen is having 1, so these are 2 molecules of hydrogen and also together with 1 oxygen. So that mass number of oxygen is 16 plus 2 is 18. So this is step 1. You have to divide them by their mass number. So the next step is you are to, when you divide them by their mass number, you will definitely have something of this nature, 0.502. Here you can get this. Then here you are going to have 1.006, while here you are going to have 2.011. So this is what you have if you press your calculator. So definitely the next step is you are to divide by the smallest. Divide both by the smallest value. So this is the second step. So which one is the smallest? In between 0.502, 1.006, and also 2.011. So definitely here 0.502 is the smallest. So we have to divide by this one. So we have to divide by also 0.502, and also divide this by 0.502. So this everything will cancel, so you have to put a ratio here. So this will be 1, where this everything will cancel everything. So here, if you press your calculator, you will get 2 as your ratio, and definitely here you are having 4. So you have gotten the ratio of your elements, the ratio of the elements in the composition. So let's go ahead. So our ratio is 1:2:4. That is the ratio. So mind you, this is the ratio of iron in the composition. This is chlorine, and also this is the ratio of water of crystallization. So definitely you are to say your formula going to be iron. Since it is only one, you cannot write anything. Then chlorine. So you are having 2 chlorine. Definitely you must put 2 here. Then you have to put then water of crystallization. 4 water of crystallization. So this is your formula. That is 1:2:4. Iron ratio 1, and also chlorine 2, and also 4 molecules of water of crystallization. So this is our answer. So the next question says, what process does each of X, Y, and Z represent in the changes shown below? That is the changes here, from liquid to gas, and also from gas to liquid, and from liquid to solid. So here, Y, from solid to gas, is sublimation. That is sublimation. From solid to gas is sublimation, and also from gas to liquid is liquefaction. And from liquid to solid, is solidification. From solid to gas is sublimation. From gas to liquid is liquefaction, and from liquid to solid is solidification. So this is the value of X, Y, and Z. Y, Z, and X. So this is the values. So this is what they literally mean. So the next question says, list the quantum numbers that are assigned to an electron in an atom. So we have only 4 quantum numbers according to the quantum theory. The first one is principal quantum number, which is always denoted by small letter n. The second one is subsidiary or azimuthal. Quantum number, which is also denoted by small letter L. The third one is magnetic quantum number, which is denoted by small letter m or ml. You can only donate magnetic by those symbols. And the last one is spin. Quantum number, which is also denoted by S or MS. So these are the 4 quantum numbers that are assigned to an electron in an atom: principal quantum number, subsidiary, magnetic, then spin quantum number. The next question said, write the electronic configuration of an element with an atomic number 15, indicating the distribution of the electrons in the energy sublevels. So here, when we write our solution, first of all, to write an electronic configuration of an element correctly, you need to know the order of spinning of atomic orbitals. That is above principle. So let's show you how to do it quickly. So you have to 1, 2, 3, 4, 5, 6, and 7. So then 2, 3, 4, 5, 6, 3, 4, 5, then 4 here. This is our blocks of element. Here you are having S block, S block, S block, then here P block, D block, and this is F block. So they are having a general arrow upon them. So this is how you can write an electronic configuration. So here, as you see this, so you have to say 1s. So definitely 1s2, 2, then remain 2s. Then you have to go back again from 2, then 2p, then 3s. Mind you, S block is always carrying 2 electrons. It will not exceed 2. So let us put 2 here again, while P is having 6, and also D occupied 10, F 14. So here we are given an element with an atomic number 15. To write down its electronic configuration together with the distribution of the electrons in the subshells. So here we are writing the electronic configuration and here are the subshells. So let's go ahead. So this is 10, 12. So we are at 3s, then 3p. 3p watt. We are looking for 15. We have a 10. Then here is 3. So to write the distribution, so this is 15. So to write the distribution, this S block is always having one degenerate orbital. S is having one degenerate orbital at all the time. But phi is having 3 degenerate orbital. So let's get a space. Sorry. It's having 3 degenerate orbital, 2p, from 2p, then 3s. So 2 is having, s is having only 1, then what again? 3p again. 3p, 3, where p degenerate orbital is having 3 shells. This is p degenerate orbital. So to write the distribution, so here we go. We have to put the first one going up, that is the spinning direction going up, then going down. Since there are 2, you must obey the Hund's rule of maximum multiplicity. So here must go up before coming down, and also here they must all go up before pairing, maintaining parallel spin. Here and also here, and also here, they must all go off. So this is the electronic configuration of this element with atomic number 15 and its distribution, as they said, in the energy sub levels. So the upper ones are the only electronic configuration, while here is showing the distributions. So the distributions of the elements. So our next question says, explain briefly the term atomic orbital. So when we say atomic orbital is a region or space around the nucleus of an atom where there is high probability of finding electron. When we say atomic orbital, is simply a shell. It's simply a shell. This is an orbital where electrons are located, while here is nucleus. So electrons are here revolving, while this is nucleus. Around the nucleus where there is high probability of finding electron. So this is what we mean by atomic orbital. So this is atomic orbital. This shell is called shell, and also it is called atomic orbital. So the next question says, two compounds X and Y have the same percentage composition by mass of 92.3% carbon at 7.7% of hydrogen. Then calculate the Roman figure 1 empirical formula of X and Y. And also Roman figure 2 molecular formula of each compound. if molar mass of X is 26 gram and Y is 17. So let's go ahead and work it. So also, as we did earlier, to find the formula or empirical formula, so the first step is to divide them by the atomic mass. So when you divide 92.3 by 12, definitely you are going to have 7.692 approximately, where here you are going to have 7.7. So you are to divide by the smallest. So definitely, without approximating, this is the smallest. 7.692. 7.692. This is the smallest, definitely. So you will have 1:1. So our empirical formula is equals to CH. This is our answer. For one figure 2 says we are to find the molecular formula. So molecular formula is empirical formula subscript N in bracket. That is, molecular formula is equals to CH N is equals to, since we are to find each molecular formula of the element, that is molecular formula for each one of them, so we are to take their molar mass. So let's find of X, where X is given in the question as 26 gram. 26 gram. So let's quickly work it. So when you come here, the mass number of this carbon and also hydrogen, this carbon is having 12 plus 1 subscript then 26 gram. Definitely you are having 13 multiplied by n. 13 n to be equals to 26. So 13n to be equals to 26. So you are to divide by the coefficient of this 26, this 13. So definitely, if you divide this, since you are looking for n, this will go. So n is equals to 2. That is to say, therefore, x at x empirical formula of x is equals to CH2, which is equivalent to C multiplied by 2, C2, H multiplied by 2, H2. So this is the molecular formula of X. That of Y, we are to do the same thing also. Molecular formula is equals to empirical formula is equals to 78, right? The mass given in the question as of Y subscript n, yeah. So will be equal to 12 plus 1 n to be equals to 78. Therefore 13n to be equals to 78. So we have to divide by 13, then definitely n is equals to 6. So as of Y, the molecular formula is going to be going to be 6 here. So therefore C multiplied by 6, C6, and also H6. So we have finally worked the questions where we have find the empirical formula and work molecular formula of X and Y depending on the mass given in the question. This question has brought us to the end of today's lesson. Keep following us where we will bring you more videos like this, where we will be working different subjects, topic by topic, as we said. So where we will be working it bit by bit so that to help our brothers and sisters staying dormantly at home during this quarantine. So thank you for watching.